In the last day's session, under the redox lesson, we started oxidation number. So I explained what is oxidation number. There's no number called reduction number. There's only a number called oxidation number. Right? So simply, what is oxidation? What is oxidation number? In order to determine oxidation number, we have two methods: algebraic method, structure method. So from the structure, how to find the oxidation number? Single example, ammonia. So when I'm asking the oxidation number, I'm pointing out an atom and asking the oxidation number. What is the oxidation number of nitrogen here? How to find? Please send your answers. When you find the oxidation number from a structure, you should know electron flow. Electronegativity values you have to recall. Fluorine 4.0, oxygen 3.5, nitrogen chlorine 3.0, carbon sulfur 2.5, phosphorus hydrogen 2.1. Likewise, when you see the values, you know nitrogen is more electronegative than hydrogen. If nitrogen is more electronegative, nitrogen gains electrons from hydrogen. Nitrogen gains electrons from hydrogen. In nitrogen gavata hydrogen ge electrons tunak wenawa, right? Nitrogen is gaining 3 electrons from hydrogen. So if I am gaining electrons, if I am gaining electron to myself like this, if I am gaining electron to myself, I'll become negative. Getting electrons means being negative. Removing electrons means losing electrons. So if I'm losing electrons, I won't become negative. Electrons lose to negative when I'll become positive. So just think you are nitrogen. You are gaining 3 electrons from hydrogen. If you are gaining 3 electrons from hydrogen, definitely you become rich in electrons. How many electrons? 3 electrons. Minus 3 is the oxidation. Right? Another example. In this example, NO4 minus I am drawing minus plus. What is the oxidation number of nitrogen? What is the oxidation number of nitrogen? Here. When you get the oxidation number, then you should understand we get electron flow plus charge. Electron flow plus charge. Charge now, you know oxygen is more electronegative than nitrogen. Oxygen's electronegativity is 3.5, right? So then 1 electron plus 1 plus 2 plus 3 plus 4. With this, electrons hadara cancel. They're removing 4 electrons, right? With this charge, it's plus 5. Oxidation number of nitrogen is plus 5. Right? Plus 5. Very good. I'm recalling the previous day's lesson, right? So then what is the oxidation number of this carbon? What is the oxidation number of this carbon? It's a live session, not a recording, right? Please use your hands. You can send your answers. Be active. Okay. So then I have received answers. Okay, very good. Right. So then here carbon, you know, oxygen is more electronegative than carbon. So then carbon loses 2 electrons to oxygen. Carbon electrons deka captain plus 2. But carbon is more electronegative than hydrogen, 2.5, 2.1. So carbon gains 2 electrons from hydrogen. So carbon is gaining 2 electrons. Carbon is losing 2 electrons. Gaining 2 electrons is minus 2. Losing 2 electrons is plus 2. So then the overall answer, very good, it's 0. Right? So then in the paper, we had some questions. I'm moving to the paper here. Paper discuss last day's paper. Right? So I couldn't discuss the last day's paper, but I have added the review also. So in this introduction to paper class 4, here, we would like to discuss question number 2. What is your answer for question number 2? Oxidation numbers of nitrogen and sulfur. What is the oxidation number of nitrogen and sulfur? Yes, send your answer number. Please take your time and send your answer number. What is the oxidation number of nitrogen and sulfur? But we received answers. Time is enough. Okay. 10 seconds more. Please select your answer number and send it. Is Oshadi, Sachi, Vishma, Tisini, Tashmi, Dahamya, Manuga, Upetma, Julaya, Tisini, Taruka. You all have given the correct answer. Very good. Tulya, Pravisha, Anjali, Kunsala. Right. Okay. That's the speed, right? What's the answer? Definitely the answer is answer number 2. Right. Why the answer is answer number 2? Nitrogen. Please draw the structure in your questions book. Otherwise it's a bit difficult. Now, you should know the electronegativity values. Hydrogen 2.1, 2.1, nitrogen 3.0, sulfur 2.5. Then mark the electron flow. Electron flow plus charge, no charge. So then hydrogen to nitrogen, it gains electrons. So I'm gaining electrons, minus 2. Another electron, minus 2. And nitrogen sulfur තමයි ප්‍රශ්නයම. ඒක තමයි gain කරනවාද මොකක්ද කියලා හිතාගන්න. So then 2.5, 3.0. Nitrogen is gaining electrons. Okay, simple ones. This is a past paper question, right? In past paper. So then here, what's the answer? Nitrogen is gaining 3 electrons to itself. Definitely, the answer is minus 3 oxidation number. Electrons මට එනවා කියන්නේ මගේ electrons වැඩි වෙනවා. Electrons වැඩි වෙනවා කියන්නේ electrons වලින් rich වෙනවා. in a negative way. Right. What about sulfur? Oxygen electronegativity is 3.5. 3.5. 3.5. So what we have to say? Oxygen is more electronegative than sulfur. Nalla pencil එකක් mark කරන්න electron flow එක. Dipole moment එක තමයි මේ. Right? So sulfur to oxygen, 1 electron is given plus 1. Sulfur to oxygen, another electron is given plus 2. Sulfur වල valence එක 6. 1 2 3 4 5 6. Electron bonds have තියෙනවා. So then plus 1 plus 2 plus 3 plus 4 plus 5. Nitrogen sulfur plus 6. Electrons have carried. Okay. You are not giving out electrons, you are removing electrons. Removing electrons means add කරනවා කියන එක, right? Add කරනවා කියන එකට මොකක්ද ගන්නෙ? Not leaving up, not removing. I mean, you have to increase the distance between electrons. Right? If you are removing electrons, they will become ions. We have to say electrons are being apart from each other. Right? Electrons add then out here. So then how many electrons were being apart? 6 electrons plus 6. So then here minus 3 plus 6, I say answer number 2. Shall we move to the next question? Right here. Okay. Yes. So this is the next question, past paper question. I need the answer for question number 4. Question number 4. Oxidation states of S1, S2. It's also a past paper question. What's your answer? Right. Taruka, first answer. Tisani, second answer. Netmi, third answer. Hashmi, next answer. Right. Upetma. Manuga, Oshadi, Dahamya, Ravini, Pravisha, Edrin, Anjali. So you can see your speed, right? මේ තමයි ඔයගොල්ලෝගේ speed එක. මම names කියනවනේ students ලාගේ. ඒ තමයි speed එක. So try to increase your speed. Right, okay. That is enough. Time is enough. So first of all, this structure is not a complete structure. If I'm asking hybridization from this, please complete this and start. Okay, complete color start karan. Sulfur valency 6, group 6 element. So then 1, 2, 3, 4. There's only 4 electrons. For the other electron, you have to put a lone pair, right? But lone pairs are not needed in oxidation number. But if I'm asking hybridization, you will be in a trouble. 1, 2, 3, 4, 5, 6. Consider the group number and fill the lone pairs. Now I'm put 1. Okay, that's it. So then oxidation number. Oxidation number means electron flow. So then sulfur to fluorine, 1, 2, 3. So releasing 3 electrons plus 3. Removing 3 electrons from sulfur, so it becomes plus 3, right? Yes. There's no electron flow here. Electronegatives are same. What about this sulfur? How many electrons will it give? Sulfur, there's no movement. But sulfur to fluorine, 1 electron is given now. Take up captain, removing 1 electron. Okay, giving out that. So that is plus 1. Is it? Plus 3 and plus 1, right? What should be the answer number? Okay, most of the students they have given answer number is answer number 3, right? Answer number 3 කියලා බලමු. හරි නේ? Answer number 3 නේ. Right, okay. So that is from the structure method, right? එටික තමයි අපිට structure එකෙන් ඒ සතේ questions තිබ්බේ. So actually it is better to do this question also from the structure. Can you do the structure of this one and get it? C2H2. Just connect 2 carbons like this. Okay, and hydrogens you have to connect it yourself. Can you get the answer for this? Question number 7. It's a challenge. Oxidation number and valency of carbon atoms in C2H2 molecule. It's a symmetrical molecule. Okay, symmetrical molecule. So try to draw the molecule around carbon valence is 4. Carbon bonds දෙකක් නම් දාන්න එපා, valence එක 4. Try to apply bonds until you are getting 4 bonds. Bonds 4ක් වෙනකන් carbon වලට bonds apply කරන්න. Lone pairs apply කරන්න එපා. Carbon is a covalent molecule. Make bonds. Question number 7. Right, okay. Answer is 1 කියලා ගොඩක් අය දලා තියෙනවා. බලමු answer එක වන්ද කියලා. C2H2. C2H2. Actually, when you are drawing C2H2 ethyne, this is the actual structure. Around carbon, there should be 4 bonds. Until you are getting 4 bonds, you have to put like this. Ethyne. So let's get oxidation number and valency. Right. Oxidation number and valency. Now what about this carbon? If you get the oxidation number, carbon to carbon, there's no electron flow. Carbon to carbon, there's no electron flow. Oxidation number is going. But from hydrogen to carbon, it gains electrons. From hydrogen to carbon, it gains electrons. Carbon electrons done. Then the oxidation number is -1. Here also, hydrogen to carbon, it gains electrons. From hydrogen, carbon gains electrons. Electrons done. So then this is -1. and oxidation number. Don't mix up. What is valency? Valency is very simple. Valency means total number of bonds. Valency by වෙන දෙයක් නැහැ. Valency කියන්නේ total number of bonds. That's it. Around a certain atom, total number of bonds. Sigma bonds, pi bonds, everything. So valency එකට charge එක ගන්නවද? ඔව්. Charge එකක් තිබ්බොත් ගන්න. Total number of bonds plus charge. Right? Okay, so then this carbon, you can see there's no charge. 1, 2, 3, 4. Valence is 4. This carbon also, valence is 4. That's it. I have to consider every bond. So what is the answer number? Okay. C2H2, oxidation number is -1, valence is 4, answer is 1. Answer is 1. Right, okay? So then let's revise how to find the oxidation number using structure. About structure from the algebraic method, how to find the oxidation number, because this is really important for redox balancing, right? So next week redox balancing, this part is really important. You can't participate to the next session, can't watch the next session before practicing this session, right? Okay, so I have written a note related to oxidation number. Now oxidation number ke note එකක් කොහොමද ලියලා තියෙන්නේ, right? So then let's discuss about that. When we find the oxidation number, there are 3 rules. Rule number 1, for standard species, oxidation number is 0. What are the standard species? If you consider oxygen, the standard species is O2. If you consider fluorine, the standard species is F2. Very good. Okay. For these standard species, the oxidation number is 0. Let's කරන්න lesson මේ lesson එක lesson එකක් නෙවෙයි nothing. හරි. ඉඳලා අහගෙන ඉන්න. හරි ආසාවෙන් කරන්න පුළුවන්. බය කරන්නේ. හරි. ගොඩක් focus කරන්න මේ lesson එකට. මොන ලස්සන lesson එකක් ඉගෙන ගන්න පුළුවන්. Because මේවා biology වල උගන්වන්නේ නැහැ මේ වගේ types. Okay. I mean this is a calculation session, right? So it's an active session like physics, right? So try to do your maximum. I mean, for standard species, oxidation number is 0. O2, F2, fluorine, like sodium, naturally available species. Actually, what is oxidation number? Oxidation number is a representation of the number of electrons which was gained by a certain atom or which has released by a certain atom. You think I'm an atom? So if my oxidation number is +4, that means I have released 4 electrons. I need 4 electrons to myself. That's an indicator. Just think my oxidation number is -3. -3. That means I have taken 3 electrons in excess. This oxidation number is 0. If the oxidation number is -3, it has taken 3 electrons itself. So it is having an ability to remove electrons, not gain electrons. So oxidation number is an indicator of the amount of electrons which has gained by a certain atom or which has released by a certain atom. Is it there? It's an indicator. Is there any number called reduction number? No. No number called reduction number. Oxidation number is only there. Oxidation number explains everything. Right. Next rule for the oxidation number. In an ion, oxidation number is equal to charge. If you get magnesium 2+, what is oxidation number? Ion එක පුතා oxidation number කියන්නේ charge. හරි ලේසි. Right? N3-, what is oxidation number? S2-, what is oxidation number? So in an ion, oxidation number is equal to charge. So this is +2, -3, and -2. Right? Yes. Next. Then the third rule, for a given atom in a molecule, okay, this thing, the molecule is CO2. In a given molecule like this, then we have to find the oxidation number of an atom. How to find the oxidation number? We have to start with the neighboring atom. We have to consider the most common oxidation state of the neighboring atom, and we have to get the oxidation number of this, right? We have to consider the most common oxidation number of the neighboring atom, and we have to take this. Again, අපි neighboring atom එකේ most common oxidation state එක අරගෙන තමයි May carbon will take. Is it clear? That is very important. So that, what is the most common oxidation number of the neighboring atom here? Yes, neighboring atom is oxygen. In oxygen, what is the most common oxidation number? Most common. How we know the most common oxidation number? Most common oxidation number means most common ion. Most common oxidation number can be most common ion, right? What is the most common ion of oxygen? In oxygen, we have O2 minus, O2 2 minus, and O2 minus. Oxide, peroxide, superoxide. But we know the most common ion is oxide. I can most common oxidation state minus. Are you lazy? Right? What is the most common oxidation state of fluorine? If the neighboring atom is fluorine, fluorine is making F minus. That is most common ion is F minus. Oxidation number is minus. Api balamu. If you have magnesium, what is the most common oxidation state? Last two. The addition of the oxidation state should be equal to 0 because the overall charge is 0. Addition of overall oxidation number, addition of all the oxidation numbers should be equal to overall charge. So here overall charge is 0, right? So then just get the oxidation number of carbon. Okay, we want to find the oxidation number of carbon. So then what we have to do, we have to consider the neighboring atom. So the neighboring atom is oxygen. We are finding the oxidation number of one carbon. So, so for one oxygen, oxidation number is minus 2. So for two oxygens, what is the oxidation number? For one oxygen, if the oxidation number is minus 2, for two oxygens, the oxidation number is minus 4. But the summation should be equal to 0. Oxidation number is addition is 0. Then what should be the oxidation number of carbon? Okay. I mean, may they add the number 0. If we add the two values, this should become 0. So you should understand, already this is minus 4. So then carbon got minus 4 when the band is 0. So then carbon should become plus 4. So then the oxidation number of carbon is plus 4. This සමහර classes වල මේක equation එකක් ලියලා ගන්න. Okay. Oxidation number of carbon එක x කියලා හිතන්න. Oxygen minus 2, then x minus 4 equal to 0. You get this minus 4 to this side, and you can solve it and find the value of x. But this will reduce your speed. That's a danger. This will reduce the speed. Don't add it to the equation. Try to get it from your mind. We need the speed. Without speed, we can't do MCQs. Okay, that's my advice. So then always try to get your mind, practice the mind. Mind method like a follow, not the equation method. Equation method is short and sweet, very simple, but it will waste your time, right? Okay, let's do some more examples. I'll erase this. I think I have given a few examples in the last day's part also. Other than that, in order to find the oxidation number, there's an exercise here. I have added Redox special exercise. Okay, so then there are 20 species you can find the oxidation number. Okay, so I have added this to your WhatsApp group. So there are 20 species you can find the oxidation number. I have underlined the atom. Okay, likewise you can find. I'll discuss some questions. Now, in carbonate, CO3 2 minus, when we find the oxidation number, how to find? That's a negative charge. So I have introduced a method. The neighboring atom is oxygen. So one oxygen is minus 2. There are 3 oxygens, that's minus 6. ඊට පස්සේ මේ 2 subtract කරන්න. නිකන් minus 6 වලින් නිකන් 2 subtract කරන්න. Minus 6 like plus 2. එහෙම විතර subtract කරන්න. Right? So minus 2 times 3 minus 6. 6 less 2. Don't think about the sign. 6 less 2 is minus 4. Okay? We had minus 6. Just less 2. It's minus 4. Then get the inverse value of that. That is plus. That's it. Basically. Minus 2 times 3 minus 6 less this 2 minus 4. Get the inverse value plus 4. Okay. So then can't we get this oxidation number by drawing the structure? We can get. But we should practice from the algebraic method. Okay. So speed is really important. Next one. So if you get Cr2O7 2 minus, what is the oxidation number of 1 chromium? Okay. Why not plus 6? Plus 6 when නැති අය කියලා හදිනවා. Plus 6 වෙන්න බෑ නේද? Minus 2 times 3 minus 6. Minus 6 වලින් මේ 2 subtract කරන්න. Minus 6 less 2 minus 4. Then you have to get the inverse value of that. Carbon is plus 4. මේක මොනවා හරි doubt එකක් තියෙනවා නම් ලියන්න equation. Right? Carbon එක x කියලා හිතන්න. 1 oxygen minus 2, 3 oxygens minus 6. ඉතින් මෙතන overall charge එකක් තියෙනවනේ. කලින් question එකේ overall charge එක 0. Yeah, there's an overall charge minus 2. So then you get this minus 6 to this side, and if you solve it, then you get plus 4. When you have an overall charge, you have to subtract this one. Right? See the last day's lesson. Minus 2 times 3 minus 6, subtract this 2. Negative එකක් තියෙනවා subtract කරලා. ඒතර minus 4 වෙනවා. Carbon එක plus 4. හරිද? තේරුණාද? What is the number? මට කියන dichromate එකේ chromium එක. Find the oxidation number of one chromium in dichromium. Speed. Yeah. And the speed එක වැඩි පාත් students ලගේ name උත් කියන. හරි. මේක දැන් කරන්නකො. මම ඊට පස්සේ example එකක් දීලා මම කියනවා අපිට ඉක්මනට answer එක එවන්න. right? ඔයගොල්ලෝ හිතන්නේ නැති example එකක් මම දෙන්නම්. ඒතර speed එක වැඩි අයට තමයි මුලින්ම answers දෙන්න ඕනේ. right? ඔය paper class එකේදීම speed එක හොඳටම තියෙනවා. right? This oxygen time is enough. Okay, I'm asking the oxidation number of one chromium. Have more answers, please send it soon. Okay, so my plus 3 කියලා කියනනේ අපිට බලා ගන්න. මෙතන. මම use කරන method එක බලන්න. One oxygen starting with the neighboring atom, one oxygen is minus 2. We have 7 oxygens. එතකොට කී minus 2 over 7 කී minus 40. ඔන්න මේක තේරෙනවා. minus 40. then එතකොට මේක plus 14 කියලා ගන්න එපා. There's a negative charge. It's not neutral. If it is minus 14, subtract this 2. Without considering the sign, subtract this. Minus 14 less 2, minus 12. Then get the inverse value of that. Inverse value of that, that is the oxidation number of these two chromiums. Then the oxidation number of one chromium is half of that plus 6. Because we believe the oxidation numbers are same. If you are writing an equation, you get oxidation number of chromium as x or y. Then 2 chromiums means 2x. Then 7 oxygens minus 14 equal to minus 2. So when you solve this, you get the answer as plus 6. Plus 6. Yeah. Right, okay. Let's move to the next example. So I would like to ask this one. S2, S4, O6, 2 minus. What is the oxidation number of one sulfur? S4, O6, 2 minus. S4, O6, 2 minus. Yes, they're waiting the answers. Oxidation number of one sulfur honey, right? एक sulfur atom में oxidation number का honey. Oxidation number of one sulfur atom. It could be a decimal value or fraction value. No issue. Negative, positive, or negative. Evanna answers. Oxidation number of one sulfur. Right, okay. Time is enough. Use the equation method also if you're not getting an answer. You can confirm the answer by the equation method, but use the mind. Right. So the oxidation number of oxygen, most common, it is minus 2. So you have 6 oxygens. I do this rough works in your getting a rough worksheet. Minus 2 times 6 minus 12. Right? Then there's a charge. There's a charge. So you have to deduct this. You have to deduct this. So then minus 12, deduct this 2, then that's minus 10. Right? Minus 12 less 2, it's minus 10. Then you have 4 sulfur atoms. 4 sulfur atoms, that is plus 10. You have 4 sulfur atoms, that is plus 10. Right? So I'm asking the oxidation number of 1 sulfur atom. I'm going to make inverse value එක තමයි sulfur 10. The sulfur 4 දෙනෙක් ඉන්නේ. S4 මේ තියෙන්නේ S4. So you have to get the oxidation number of 1 sulfur. මේ 4 දෙනෙක් 10 නම් එකෙනෙක් කියනවා. Right? 10 divided by 4. 10 divided by 4 means 2.5. Okay? So then oxidation number of 1 sulfur atom is 2.5. 2.5. Right? Okay. So we received the first answer. මම කියන්නම් මුලින්ම answer එක අපිට හරියටම කවුද දෙන්නේ කියලා. Q1. Right. The first answer we received from NetMe. NetMe Navodaya. Right? So congratulations on your speed drive. Next one from Taruka. And then we received the next one from Vishma. I think. Yes. Dahamya. Binadi. Manuga. Tisani. Upetma. Rashmi. Tulya. Isuri. Tisimi. Anjali. Ravini. Okay. Julaiha. And that's all. I've given only the correct answer, right? Answer ka හරියට දුන්නාගේ names විතරයි මම කිව්වේ. That's the speed. So අනිත් අය try එකක් දෙමු line. හරි. board එක clear කරන්න. Mind එක. Speed එක mind එක. Right? Accuracy. Everything. Start with the neighboring atom. Otherwise, when you get oxygen, if you are directly saying -2, that's incorrect. Okay. Start with neighboring atom. Be very careful. Right? Okay. So simple question. In H2O2, what is the oxidation number of 1 oxygen? H2O2, oxidation number of 1 oxygen. Okay. Then receiving many more answers. H2O2, oxidation number of 1 oxygen. If you are saying 1, you should specifically say whether it is +1 or -1, right? If it is -1, that is specified. Right? How to find this? Start with the neighboring atom. Neighboring atom is hydrogen. What is the most common oxidation number of hydrogen? In hydrogen, the most common ion is H+. In hydrogen, the most common ion is H+. So we have 2 hydrogens here. 2 hydrogens means, okay, from these 2 hydrogens, oxidation number is +2. You know the overall value is 0 here. No charge, overall value is 0. That means 2 oxygens should have the oxidation number. 2 oxygens should have the oxidation number called -2. So then what is the oxidation number of 1 oxygen? So what is the oxidation number of 1 oxygen? -1. If 2 oxygens are having oxidation number -2, 1 oxygen is -1. If you remember in H2O2, the oxidation number of oxygen is -1. Right? Okay. So we received the first answer. Okay. Actually, there are many more answers. Can't read everything, right? From Binadi, right? Binadi. Then Taruka, Manuga, not Manuga, but that answer is incorrect. Tisani, Netme, Vishma, Pravesha, Dahamya, Upetma, Tashimi is okay, likewise, right? Okay, who's joining now? All right. Yes, so abhi ek minute exercise key back. Right, in KO2, what is the oxidation number of oxygen? In KO2, what is the oxidation number of one oxygen? One oxygen. Right. As they also have done this. Be careful, right? Try to give the specific answer at once. Oxidation number of one oxygen. You are saying minus one. One oxygen I'm asking. Is it minus one or minus half? Right? So you should know neighboring atom is potassium. The common oxidation number of potassium is plus one. Right? So then overall charge is zero. Overall charge is zero. So your oxidation number should be equal to zero. And then the two oxygens should have minus one. The oxidation number is minus one heavy. Because minus one can put the two oxygens. So concentrate there. Two oxygens. So then for one oxygen, it's minus half. Minus half. Right? That's the point. Minus half. Right, okay. Next one. In IO minus, what is the oxidation number of iodine? IO minus. Start with the neighboring atom. If you want, you can write it the equation. We go back to the answer. Equation equation try to write the equation also. Be difficult. Equation mix up. Equation is always giving the correct answer. Sometimes when you are doing some mind, you are doing some careless mistakes. But okay, is it plus one or minus one? I did plus one or minus one? I or minus? Plus one or minus one? Get your time. Why is it not minus one? This is plus one. Okay. So how to use mind? Mind method they common use correct? Name. Oxygen, neighboring atom. Most common oxidation state is minus two. That's why monkey make a subtract. Minus one can 1 2 just subtract 1. Just subtract 1 without considering sign. 2 1 gamma, but which one? The sign is there, right? Okay. Sign is there, do not forget. I mean, the sign you have to take like this. Then 2 subtract this. 2 subtract that value is 1. That's minus 1. So then get the inverse value of that. Then get the inverse value. So then this iodine is plus 1. Or the equation. Iodine, consider the oxidation number as X. Then this oxygen, critical. That's what I'm telling you to write the equation. This oxygen, most common, minus 2, equal to the overall charge. It's minus 1. So then when you solve this, you get the answer as plus 1. Simple. Clear? Right, okay? These are the examples. Let's get another one. H2, S2, O8. What is the oxidation number of one sulfur? Oxidation number of one sulfur. Please send your answers. H2, S2, O8. එක සල්ෆර් එක අහලා තිබ්බේ Right, okay. I'm going to discuss. Udala, how many? Plus 7 ke. Oxidation number plus 7 and on. Hydrogen. Two hydrogens here. Most common. One hydrogen is plus 1, two hydrogens plus 2. 8 oxygens. One oxygen is minus 2, 8 oxygens minus 16. What is the solve? Minus 16 plus 2. This is solve the charge opposite. Make overall 0 will equal then. Right? Minus 16 plus 2 minus 40. Minus 40. Then what should be the oxidation number of these two sulfurs? Plus 40. Oxidation numbers of these two sulfurs is plus 40. Then what is the oxidation number of one sulfur? Plus 7. Isn't it? 2 times 8 minus 16. Minus 8, 16 plus 2 minus 14. Then these two sulfurs should have plus 14. One sulfur is plus 7. That's it. Is it clear? Okay. Oxidation number. Right? Okay, we are moving to a past paper question here. So then you can do this exercise at home, right? You can do this exercise at home. This is the tube. Okay, redox balancing special exercise. This is the first part, and then this is the half ionic part. Okay, we're discussing this part today, and then basic medium. Okay, next week we'll be discussing these cases, right? Okay. So however, this tube is used for these 3 weeks. Okay, so then you can do these things at home. I am asking the answer for this question, right? The last week's paper. What is the answer for the first question? Please try to get the answer. First question. The correct answer, when the molecules O2, H2O, H2O2, OF2, O2, F2 arrange in the decreasing order of oxidation state. Please arrange the oxidation state for one atom. What is your answer? Right, okay. So we're going to discuss. What's the answer number? Ascending order. Samara ascending order question. Decreasing order. Hurry. What I can answer 2 kino, Samara 5 kino, 2 the 5. Is it 2 or 5? It's 2018 level. This question. 18. Okay, this piece is O2, H2O, H2O2, OF2, O2, F2. Arrange in the decreasing order of the oxidation state. Right here. So when you get the oxidation state of oxygen, that's 0. And then in water, 2 hydrogens plus 2. And then this oxygen minus 2. H2O2, 2 hydrogens plus 2. 2 oxygens minus 2. But 1 oxygen we are asking. 1 oxygen minus 1. In OF2, neighboring atom is fluorine. Don't forget. So fluorine most common oxidation state is minus 1, 2 fluorines minus 2, and then this oxygen is plus 2. Right? So then the oxidation number of oxygen is plus 2. What about O2F2? Here 2 fluorines minus 2. 2 oxygens plus 2. 1 oxygen plus 1. So how to arrange this in decreasing order? Decreasing order means decreasing. So highest value we have to start OF2. ඒක තමයි highest එක. right? when answers වල decreasing order කොහොමද තියෙන්නේ කියලා. Decreasing order. So in answer number 5 you can see this is highest plus 2 plus 1 next highest 0 minus 1 minus 2, right? Decreasing order means this is the largest value and then you should decrease this way, right? Because this inequality sign suggests this side is large, right? This side එක වැඩි. හරි නේද? පුතාලා. Okay, next question. I would like to discuss this one also. What is the answer here? Okay. Try to give me the answer. It's 2009 A levels. Which of the following molecules ions nitrogen's oxidation state -3 0 plus -3 0 plus 3 වෙන කාගෙද? එවන් answers. Check කරන්න. -3 0 plus 3. That okay. පුතාලා answer එක බලන්න. Okay, I'm discussing in the board now. -3 0 plus 3. NH4 plus N2 NH2 minus NO2 NO2 plus තව තියෙනවා N2O3 N2H4 NCl3. Right. So please get your notebook. Please get your questions book or notebook, any book, and mention the oxidation state of nitrogen here for these species. 1, 2, 3, 4, 5, 6, 7, 8. So I'll give 8 out of what? Mention the oxidation state of nitrogen here. I mean oxidation state of one nitrogen atom. Let's take 8 out of what is the score you get? 1 minute. It's 1 minute is over. Check your answers. Hi, answers pal. And let's say I'm here. NH4 plus. So when we have when you have a positive case, use the equation. That's my advice. Positive equation use right? I mean, nitrogen take the oxidation number as X. 4 hydrogens plus 4 is equal to plus 1. Right? In a positive case, try to use the equation. When you put this plus 4 to here, plus 4 minus 4, then minus 4 plus 1 minus 3. Nitrogen is minus 3. Right? N2, 0. Then this NH2 minus is also a critical thing. Better to use the equation. In a challenge, try to use the equation, right? Nitrogen is X. 2 hydrogens. Redox the equation is only there, but me wage wadi chupa. Amaro question chupa difficult wage hituna. Use the equation. 2 hydrogens plus 2 equal to this charge minus. Then solve it nicely. Plus 2 to here, minus 2, minus 1, minus 2, minus 2. NO2. You want an equation so on. 1 oxygen is minus 2, 2 oxygens minus 4, nitrogen is plus 4. And positive equation use kara. Nitrogen X. 2 oxygens minus 4 should be equal to this charge plus 1. Then you put this minus 4 to this side. So then plus 4 plus 1 is plus 5. Right. Then N2O3, 1 oxygen is minus 2, 3 oxygens minus 6, 2 nitrogens plus 6, 1 nitrogen plus 3. N2H4, 4 hydrogens plus 4, 2 nitrogens minus 4, then 1 nitrogen minus 2. NCl3, 1 chlorine is minus 1, 3 chlorines minus 3. This nitrogen should have plus 3. Chlorine minus 1, plus 1 never. Right? Neighboring king start karanone. So then minus 3 plus 3. Well, overall like 0 benefit. Put 8 out of what? How the 8 out of 8 get it? Right, very good. Have to concentrate your knowledge, right? This oxidation number. Right, with the oxidation number exercise, other lesson again. Right, other lesson again. So from here onwards, we are starting redox. Right, and this lesson again refresh right? Alright, and take your notebook. So we discuss equation balancing equations, right? Nuclear equations, chemical equations, inspection method, oxidation number, and then this is redox. Okay. So balancing equations using redox method. Write the topic. Balancing equations using redox method. Notebook. Please write the note. Okay. Balancing equations using redox method. Right. Then this is the next topic. Next topic. Small topic, subtopic. Definition of redox. Definition of redox. Definition of redox. Yeah. Ox means what? All of us. Ox. Oxidation. Red means red. Reduction. Reduction. So then this redox word, it's a combination of two processes called oxidation and reduction. Right? Oxidation and reduction. So let's see what is oxidation and what is reduction. What are the definitions for this? Right? So actually when we are defining redox, we use four stages. Okay. Number one, using electrons. Number two, using oxidation number. Using oxidation number. Number three, using the number of oxygens. Number four, don't write anything. Using number of hydrogens. Hydrogens. Number one. We can explain oxidation using electrons. Okay. Whether the removal of electrons or is it gaining electrons. If you are removing electrons or gaining electrons. See here. Right. So now zinc. I'm telling zinc is converted into zinc plus. Zinc is converted into zinc plus. Right. It's an oxidation. Why we say this oxidation? Let's see why is it. Actually, if I'm saying in order to balance this equation, put electrons, to which side you put electrons? I mean, in this equation, the charge is not balanced. Zinc charge is 0. Zinc 2 plus, charge is plus 2. Right? This is charge is 0, this is plus 2. If I'm giving electrons to you to balance this, to which side you add electrons? You do add electrons to here. If you're adding electrons here, you can't balance the charge. Electrons may add charge balance. Right? I mean, either sides you should make the same charge. So definitely you should add 2 electrons to this side. And it will give minus 2. Minus 2 plus 2 balance 0, 0. Yeah. We add electrons to balance the charge. Yeah. Right. So what we can say about electrons? If you are removing electrons or if the electrons are giving out, that is oxidation. Right? If we remove electrons in a chemical reaction, okay, that's an oxidation. That's an oxidation. Right? You remember removal of electrons or giving out electrons. Removal of electrons. Right? So when electrons are removed, let's see the next one. The reduction, what would happen? Fe3 plus is converted to Fe2 plus. This is a reduction. To which side you put electrons? To which side you put electrons? I mean, we are adding electrons to balance the charge. Is it left or right? Plus 3, plus 2. What is plus 3 plus 2? Oxidation number. Oxidation number of an ion is equal to charge. Here the oxidation number is plus 3. Here the oxidation number is plus 2. That's the charge. You have to balance the charge either side is using electrons. To which side you add electrons? Definitely to the left side you have to add electrons. Right? So you have to add an electron here. Right? That is minus 1. Plus 3 minus 1, it's plus 2. Plus 3 minus 1, it's plus 2. So this is plus 2. And here also we have plus 2. right? So plus 2 plus 2. So that means it is acceptance of electrons, gaining electrons. So if I am gaining electron to myself, I am being undergoing reduction. I'm undergoing reduction. So then you should understand acceptance of electrons. Simply gaining of electrons. Acceptance of electrons, gaining electrons. Right. Exam එක අහන්නේ define oxidation, define reduction. Jadi ගොඩක් වැඩ තියෙනවා. Right? Yes. අන්න බලන්න oxidation number. In oxidation, what will happen to the oxidation number? Just see this. Now you can say. In oxidation, what will happen to the oxidation number? Consider the oxidation number in the left side and right side. Yes, consider. Will it increase or decrease? Yes, zinc. What is the oxidation number? The standard species. 0. So zinc 2 plus the oxidation number plus 2. So will it increase or decrease? So definitely in oxidation, we should know the oxidation number is right. The oxidation number is increased. Increase in the oxidation number. The oxidation number is very big. Can write the same example for that one also. Zinc to zinc 2 plus. Here 0 and here plus 2. And the oxidation number increases, it's oxidation. In reduction, what will happen? Oxidation number. In reduction, what will happen with the oxidation number of the species? Decreases. Right? Very simple. So then reduction means decreasing the oxidation number. You can get any definition. It's plus 3 here and here plus 2. Just have to say decreases. Decreases. Right? Okay. Last two definitions. See this one. These two definitions we are using in organic chemistry only. Right? You won't be getting these two definitions easily. In organic chemistry, we use these examples. Right? Now, see this example, right? CH3, CH2, OH. CH3, CH2, OH. And it is converted into CH3, C double OH. C double OH. I'm asking the forward reaction, is it oxidation or reduction? When you determine that, you can see this CH3 is same here. You know, this CH3 is same. Both CH3s are same. Do not consider that. There's no oxidation difference. If it is same, there's no oxidation change. Consider the next carbon. Consider this carbon. What is the oxidation number of this? Carbon oxidation number and find the oxidation number of this carbon. And then determine whether it is oxidation or reduction. If your oxidation number has increased, you are undergoing oxidation. If your oxidation number is decreased, you are undergoing reduction. Rocket science very simple. Work out structure method use follow the structure method. Structure can gun organic molecules. Right? Take the oxidation number of this carbon and the other carbon, and then see whether it's increasing or decreasing. If it is increasing, it's an oxidation. If it is decreasing, it's a reduction. Just tell me it's an oxidation or reduction. Forward reaction. Look how the reduction. Check the oxidation numbers really well. Strictly check करना. Then have you finished? If you finished, please tell me. Right, okay. Now this one. Actually, oxidation number of this, see here. Now this carbon is gaining 2 electrons from hydrogen. Carbon is more electronegative than hydrogen. Carbon is gaining 2 electrons from hydrogen. If I'm gaining 2 electrons, I'll become -2. Then towards oxygen, I have to give out electrons. Because oxygen is more electronegative than carbon. Oxygen is more electronegative than carbon, so you're removing 1 electron. And you can gain 2 electrons from hydrogen. So then carbon will gain 2 electrons and you will lose 1 electron. As it is gaining 2 electrons, it's -2. As you're losing 1 electron, it's +1. Right? Gaining 2 electrons means -2. Losing 1 electron means +1. So -2 plus 1 means what? -2 plus 1. -1. -1. And then here, this carbon, how many electrons? There's no electron flow here. You're removing 1 electron for this oxygen, +1. Removing another electron, +2. Removing another electron, +3. Then this is +3. +3. So -1 to +3, you can see the forward reaction, it is an oxidation because increasing oxidation now. It's an oxidation, right? -1 to +3, it's an oxidation. That's the point we have to follow. Right, okay. I'm not going to, actually my focus is the number of oxygens. What will happen to the number of oxygens? Here, how many oxygens you have? 1 oxygen. Here, how many oxygens we have? 2 oxygens. So you can see when the oxidation is taking place, what will happen to the number of oxygens? Simply oxidation means oxidation. D-A-D-A-T-I-O-N. Oxidation. Addition of oxygen. In oxidation, what will happen? The number of oxygens will increase. Oxygen වැඩි වෙන එක තමයි oxidation. So check the hydrogens. So when you check the overall hydrogens, 3, 2, 1. Here we have 6 hydrogens. And here we have 4 hydrogens. 6 to 4. So the number of hydrogens is decreasing. Number of oxygens is increasing. This process is oxidation. Right? So in the process oxidation, the number of oxygens increases, the number of hydrogens decreases. Okay? This is a good example. The forward reaction is oxidation. So how I am saying forward reaction is oxidation? Because oxidation number has increased, right? -1 to +. So the backward reaction, that is reduction. Okay, if this species is converted into this. So in the reduction, you can see number of oxygens decreases, number of hydrogens increases. Always hydrogens are removed to attach oxygen. Always oxygens are removed to attach hydrogen. It's happening opposite ways, right? Okay, so then in oxidation, you can write the number of oxygens increased. I'm writing in a small font, right? The number of hydrogens decreased in oxidation. And if parallelly, you can write the number of oxygens here decreased. Okay, oxygens. The number of hydrogens increased. Hydrogens. And okay, please complete the table. Complete the table with the examples. So these are the definitions for redox. Is it clear? Any questions? If you have any questions, please ask. Right, copy down this notebook. Where do you have finished? We're going to move to the next one. Okay. Few seconds more. Okay. So I have added a photo of this also to your WhatsApp group. It's available. You can download it and you can write it nicely. Next topic. Standard oxidations and reductions. It's really important. This table is very important, right? Going to erase. Then hereafter, if you want to keep remember what is oxidation, just keep remember the second one. Second one is most important. Increasing oxidation number is oxidation. Decreasing oxidation number is reduction, right? Increasing oxidation number is oxidation. Decreasing oxidation number is reduction, right? Ready topic? Standard oxidations and reductions. Standard oxidations and reductions. Right. Then listen well. Separate your page into two sections. Page right? Two sections. One side, standard oxidation. Standard oxidation. The other side, standard reduction. The other side, standard reduction. Oxidation, reduction. Oxidation, reduction, right? Yes. So I'm giving the conversion, this to this. You have to state whether it's oxidation or a reduction. How to identify whether it's oxidation or reduction? Just find the oxidation numbers at left side and right side. Then by experience, you will be getting, is it oxidation or reduction? Okay? And then if it is an oxidation, put it into this column. If it is a reduction, put it to this column. I'm not specifically giving it as oxidation or reduction. You have to work out. You have to find the oxidation number of one atom to get it. Right, okay, see this example. Number one, okay, to get an example like this, Fe2 plus is converted into Fe3 plus. This is very, very simple, right? Is it oxidation or reduction? Just see the oxidation number at the left side. So that you have to work out now, okay? Is it oxidation or reduction? This Fe, what is the oxidation number? Plus 2. This Fe3 plus, what is the oxidation number? Plus 3. So then just determine whether the oxidation number has increased or decreased. Is it increased or decreased? Plus 2 to plus 3. Plus 2 to plus 3. This way. Increased. So if the oxidation number has increased, you should write it here as a standard oxidation. What is a standard oxidation? In the exam, they won't give Fe2 plus is oxidized into Fe3 plus. You should know it. It's a basic thing. Right? That's what we are writing. In the exam, they just give Fe2 plus only. You should know it's oxidized into Fe3 plus. You have to study it. Right? Okay. Likewise. Second example. MnO4 minus in acidic medium only, it converts to Mn2 plus. Oxidation or reduction. Just determine the oxidation number. For what? For which atom? Okay. Common sense. No need to determine the oxidation number of oxygen, right? Because it's not available either sides. The atom which is available either sides is manganese. Just determine the oxidation number of one manganese atom, and then tell me whether it's oxidation or reduction. Whether it's oxidation or reduction. එක manganese එකක් හොයන්න. Mind එකෙන් use කරන්න, right? Mind method. So when we find the oxidation number, one oxygen, okay, algebraic method. One oxygen minus 2, 4 oxygens minus 8. Minus 8. So then from that minus 8, subtract this. From that minus 8, subtract this. Minus 2 times 4, minus 8. So from that minus 8, subtract this. That's minus 8 less this, right? Minus 8 less this 1, that's minus 7. Then what is the oxidation number of manganese? Plus 7. Right? What is the oxidation number of manganese? Plus 7. Then what is the oxidation number of this manganese? Plus 2. So with the plus 7 to plus 2, you are decreasing the oxidation number. So if you are decreasing the oxidation number, that's a reduction. Should write it here. Clear? Likewise. So the next example. C2O42 minus to CO2. Which atom we have to consider when we are discussing about the oxidation or reduction? When we are finding the oxidation or reduction, we consider oxygen or carbon. That's a trouble. Should know generally. Sorry. Generally, we have to find the oxidation number of the electropositive atom. Electropositive atom क्या है? That's a tradition. It's not always correct. It's not always correct, but in most of the cases, except hydrogen and oxygen, for hydrogen and oxygen, except for hydrogen and oxygen, that is true. When you have few atoms like this, just find the oxidation number of the electropositive atom. What is electropositive atom? The atom with the lowest electronegativity. You know, oxygen is more electronegative than carbon. So don't find the oxidation number of oxygen. It's always the same. Try to find the oxidation number of the electropositive atom. You can write that. Okay. So then electropositive atom is carbon. Find the oxidation number of one carbon atom. Either sides. One carbon. Get the oxidation number of one carbon atom either sides. And then determine whether it's an oxidation or a reduction. Find the oxidation number for one carbon atom. So then how to find? It's the algebraic method. Right, okay. Carbon. So, again, one oxygen is minus 2. When you have 4 oxygens, minus 8. When you have 4 oxygens, minus 8. So from that minus 8, subtract this 2. Minus 8 less this 2, minus 6. Then get the inverse value. For these two carbons, it's plus 6. One carbon, plus 3. One carbon is plus 3. Okay. Okay, what about CO2? Oxidation number of carbon. One oxygen is minus 2. Two oxygens, minus 4. Then what is the oxidation number of carbon? Plus 4. So you can see, when we determine the oxidation number of one carbon atom, we can identify the oxidation number has increased. Plus 3 to plus 4. So as the oxidation number has increased, it's an oxidation, right? C2O42 minus 2CO2. Okay, first of all, put this down. No need to write this thing, right? No need to write these things. You can write these ones in your rough worksheets and then categorize correctly as standard oxidation or reduction. Start with this. Then I will write few equations. Then you can sort out. I have to find the oxidation number of one atom. If the same atoms available either sides, check the electropositive one. Check the electropositive one. It's always correct unless for hydrogen and oxygen. When hydrogen and oxygen is available, we check the oxidation number of oxygen, not hydrogen. But in all the other cases, electropositive atom is working. If you have finished, tell me. You can give more examples. There's a question. I got disconnected. Should we write the note that you sent in the group? Yes, definitely. I think previously we have given redox definitions. You should write it first and then write this one. Only definitions of redox, then make. Right. Yes, so I'll give more. Is categorized as oxidation or reduction. Right? S2O3 2 minus S2O3 2 minus converts to S4O6 2 minus NO2 minus NO3 minus MnO4 minus basic medium convert into MnO2 SO2 SO4 2 minus IO3 minus 2I2 Cl minus to Cl2 Cr2O7 2 minus to Cr3 plus H2O2 to O2. First arrange these species. These can be oxidations or reductions, right? You should categorize it in the correct column. So write these ones in a rough worksheet and then determine the oxidation number of one atom. So here one sulfur atom, it's electropositive. Here one nitrogen atom, here one manganese, here one sulfur. It's very simple. Start doing it. Determine the oxidation number of one atom. If you finish, tell me. Right? I'm on to the next category. In the last one also, in the last one, you can determine the oxidation number of oxygen. In all the other cases, it's very simple. Try to determine the oxidation number of one atom, right? There can be 2 atoms, 3 atoms, 4 atoms. But either sides try to determine the oxidation number for one atom. Then you can understand whether it is increasing or decreasing. If it is increasing, it's an oxidation. If it is decreasing, it's a reduction. Right, okay. Can finish? We can discuss. Finish this. Sort out. You need more time. Right, I'll give the time. I'll find the oxidation number of one species, one atom. Electropositive atom. And then just determine whether it is increasing or decreasing. The oxidation number is increasing, it's an oxidation. If the oxidation number is decreasing, that's a reduction. Right? Can give more time. Just do this exercise now, right? Do some discussing after we are completing. Right? So discuss first 1, 2, 3, 4. Palani hata discuss karan. First 4. Because I put timer then. Right. Just listen well. S2O32 minus, determine the oxidation number of one sulfur atom. Be very careful on this. Okay, with the figure. So when one oxygen is -2, 3 oxygens -6. 3 oxygens -6. So from that -6, subtract this 2. I must send it back in -6, subtract 2, -4. Then get the opposite charge. Opposite charge, +4. But for +4 means for 2 sulfur atoms. For 2 sulfur atoms, +4. The sulfur only one. For 1 sulfur atom, what is the value? 1 sulfur atom +2. And now I'm calculate. How do you see it? So then try to use your mind, right? Don't use algebraic method here. I mean equations method. You will be more slow, right? So then here -2 times 6. Practice when -2 times 6 -12. -12 less 2 -10. -10. Then get the opposite charge of that +10. So +10 means for 4 sulfur atoms. For 4 sulfur atoms, it's +10. So for 1 sulfur atom, it is +2.5. +2.5. So it is clear. +2 to +2.5, increasing the oxidation number, it's an oxidation. So you can write it here. S2O32 minus to S4O62 minus is an oxidation. Sulfate to tetrapannate oxidation. Here to this arrow. Next one. NO2 minus NO3 minus. What is the oxidation number? 1 oxygen -2. 2 oxygens. -2 times 2 -4. -4 वाले make adu karan. Okay. -3 with the opposite charge. +3. Not again. And this one -2 times 3 -6. -6 less this one -5. And this nitrogen is +5. So +3 to +5. +3 to +5. It's an oxidation. Right? So you write it here. NO2 minus to NO3 minus is an oxidation. It's very important to understand like this. Next one, is it oxidation or reduction? We have calculated. What are the oxidation numbers? Give with reasons. This to this, oxidation. This to this, reduction. Mention the two oxidation numbers also within brackets. Reduction, this to this. That's the proof. What's your idea? So if it is a reduction, you should mention the transmission of the oxidation number, this to this. Very good. Is it plus 6 to plus 4? Plus 6 or plus 7? Try to find manganese, one atom, one manganese atom. Either sides. Is it a reduction? Plus 7 to plus 4. Now, manganese is plus 7 MnO4 minus. Minus 2 times 4 minus 8. This is practice. Minus 2 times 4 minus 8. Minus 8 bali make aduka. Minus 8 less that one. Minus 7 okay, opposite egg. Plus 7. And the manganese oxidation number right? And that. So here no charge. So then 2 oxygens minus 4. In order equal to 0, manganese should have plus 4. This is plus 4. So the plus 7 to plus 4. Plus 7 to plus 4 is a reduction. You write it here. MnO4 minus is in acidic medium. Mention H plus. You have two mediums, acidic medium and basic medium. Only this equation is different like that. And make a Venus when permanganate reduction reduces to H plus. Sorry, permanganate reduces to Mn2 plus in acidic medium. Permanganate reduces to MnO2 in basic medium. Other than this species, all the other reactions are common for acidic and basic both. We don't want to worry about them. Okay? In acidic medium, we use H plus to balance. In basic medium, we use OH minus to balance. MnO4 minus in basic medium convert into MnO. MnO. The SO2 to SO42 minus oxidation or reduction. Oxidation or reduction. What is the proof? Yes, send the answer. SO2 to SO42 minus. Why we are saying it's oxidation? Can you mention the oxidation difference? Which atom we are considering the oxidation? Definitely electropositive atom. So the oxygen and sulfur electropositive when sulfur. Electronegativity aduken. Right. So what is the transmission? So here one oxygen is minus 2, 2 oxygens minus 4, the sulfur plus 4. Sulfur plus 4. The other side. One oxygen is minus 2, 4 oxygens minus 8. From that minus 8, subtract this 2, minus 6, then this sulfur plus 6. The plus 4 to plus 6, plus 4 to plus 6. Increase in the oxidation number. Right? So then that is SO2 to SO42 minus. On oxidation. SO2 to SO42 minus oxidation. Okay, I'll give 1 minute to finish this. Who have finished? Okay. How do you reckon the 1, 2, 3, 4. 1 minute. Yes, Tulya, Julia. Yes, Vinadi, Kunsala, Adri, Isini, Dahamya, Anuga, Sachi, Karuka. Very good. Pravini, Kurakaivarai. Yes, very good. So we can balance redox equations. After this, we can pass the current redox balance. Okay? Right, okay. Most of the students have finished. So let's start. IO3 minus to I2. In IO3 minus, what is the oxidation number of iodine? 1 iodine atom. Minus 2 times 3 minus 6. Minus 6 less this minus 5. The opposite charge of that iodine plus 5. So then here 2 iodines 0. Iodine they could 0, he could 0. So then put that plus 5 to 0, reduction. IO3 minus 2I2, reduction. Then calculate gram. Right? It's a good exercise. Next one. Is it oxidation or reduction? One atom. Cl minus, oxidation number is -1. Cl2, oxidation number is 0. -1 to 0, it's an oxidation. Dichromate. Determine the oxidation number for one chromium atom. 7 oxygens, -2 times 7, -14. -2 times 7, -14. -14 less 2. -14 less 2. -12. Then the 2 chromium should have +12. 2 chromium should have +12. 1 chromium +6. Then the other chromium, Cr3 plus, oxidation number of an ion is equal to charge +3. So dichromate to Cr3 plus means oxidation number is changing from +6 to +3. It's a reduction. Okay. Cr2O7 2 minus convert into Cr3 plus. It's a reduction. Cr2O7 2 minus is converted to Cr3 plus. Then H2O2 to O2. H2O2 to O2. What is the oxidation number of H2O2? Make it careful. Hydrogen check hydrogen check the oxidation number of oxygen. So you know hydrogen, for 2 hydrogens oxidation number is +2. 2 hydrogens. Then for 2 oxygens oxidation number is -2. 2 oxygens. So for 1 oxygen oxidation number is -1. -1 is the oxidation number of 1 oxygen. Right? Then O2 oxidation number is 0. -1 to 0 oxidation. -1 to 0 oxidation. So H2O2 to O2, it's an oxidation. H2O2 to O2, it's an oxidation. Okay. So I'm giving more. Right? I'm erasing this part. Yes, next. H2O2 to what? Ammonia to N2. Aluminium to aluminum. H2S to sulfur. OCl minus to Cl minus. SO2 to sulfur. ASO3 3 minus to ASO4 3 minus. Right, okay. Put this down. Sort out whether it's an oxidation or reduction. That's the last part. So then the first one is very important here. In the first one, keep remember this is very, very special. You don't check the oxidation number of hydrogen. You can hydrogen check an exception again. I mean, when you check the oxidation number of this one, hydrogen is same. Check the oxidation number of oxygen, considering hydrogen as +1. Okay. Just check the oxidation number of oxygen, not hydrogen. Okay. Check the oxidation number of oxygen, then you will identify whether this is oxidation or reduction. H2O2 can oxidize and reduce at the same time. Right? You have to decide whether it's oxidation or reduction depending on the other species. It can undergo oxidation as well as reduction. This OH minus means the medium, right? LO2 minus. Okay, just work out this. find the oxidation number of one atom and categorize it. Yes, Fudala. Discuss karo. Right, okay. Yes, here we go. So I have to erase the board because we should write this. Oh, I'll label this here itself. I'll label it. Right, okay. H2O to water. Is it oxidation or reduction? We found that. Find the oxidation number of oxygen, right? Now here 2 hydrogens plus 2. 2 hydrogens plus 2. I think start karane. 2 oxygens minus 2. 1 oxygen minus 1. And here 2 hydrogens plus 2. 1 oxygen is minus 2. So minus 1 to minus 2. Minus 1 to minus 2 means decrease in the oxidation number. It's a reduction. So then this is a reduction. Reduction. Next one, ammonia to N2. In ammonia, what is the oxidation number of nitrogen? Minus 3. Minus 3. In nitrogen, what is the oxidation number of nitrogen? 0. Minus 3 to 0 is oxidation. So you have to categorize it under oxidation. Aluminium to aluminate. The aluminium is 0. In aluminate, what is the oxidation number of aluminum? 1 oxygen is minus 2, 2 oxygens minus 4. Minus 4 less this one, minus 3. Get the inverse of that. Plus 3. Plus 3, 0 to plus 3, it's an oxidation. H2S to sulfur. 2 hydrogens plus 2, and then this sulfur is minus 2. 2 hydrogen is plus 2, sulfur is minus 2. This sulfur, 0. So then minus 2 to 0 means oxidation. Minus 2 to 0 means oxidation. Right? Oxidation. Next one, OCl minus. I've given the oxidation number of this chlorine. Okay. But oxidation number of chlorine is plus 1. Plus 1, not minus 1. Oxidation number of this chlorine is minus 1. Plus 1 to minus 1, it's a reduction. It's a reduction. SO2 to sulfur. 1 sulfur is plus 4 here. This sulfur is 0. Plus 4 to 0, it's a reduction. Plus 4 to 0, it's a reduction. AsO4 3 minus, AsO3 3 minus. AsO3 3 minus, AsO4 3 minus. How to find? Minus 2 times 3 minus 6. Minus 2 times 3 minus 6. Minus 6 less this 3. Minus 3. This arsenic should have plus 3. As can arsenic can. Then minus 2 times 4 minus 8. Minus 8 plus 3 minus 5. Then this arsenic is plus 5. So plus 3 to plus 5. It's an oxidation. Oxidation. Let's put this down. Oxidation reduction. I would have put off this also. This table is very important. But okay. Next topic. Another topic. Balancing redox reactions using half ionic method. Balancing redox reactions using half ionic method. Balancing redox reactions using half ionic method. Right, okay. Redox procedure. This is the redox procedure. I mean, I'm writing the note how to balance the equations. This is very important. So then just listen well. Right? Everything I'm explaining here. Yes, how to balance half ionic. I mean, in order to balance redox equations, we have two methods: half ionic method, exchanging oxidation numbers method. Right? What are the two methods? Half ionic method, exchanging oxidation numbers. What is half ionic method? Writing oxidation reaction, writing reduction reaction, and then adding it to get the ionic equation. Again, oxidation එක වෙනම ලියන්න. reduction එක ආයෙ ලියන්න. ඊට පස්සේ ඒ දෙක add කරලා overall එක ගන්න. මේක තමයි balance ionic එක කියලා කියන්නේ. කියන්නේ balance ionic එක එකපාරට ගන්නෙ නැහැ. දැනවද? stages තුනකින් එන්නේ. මේ half ionic. අපි එතනින් start කරමු. but තව method එකක් තියෙනවා exchanging oxidation numbers. In exchanging oxidation numbers, directly we get the balance ionic equation. Generally, when I'm balancing, I'm using exchanging oxidation numbers method because in the exam they won't tell to use half ionic method, right? Short and sweet. One step we can balance the entire equation when we are using exchanging oxidation numbers method. So why we are giving it in the second case? Because you should know half ionic method before moving to the exchanging oxidation numbers method because it's a bit complex, right? Balancing redox reactions using half ionic method. Under that, I'm going to write the procedure, right? Procedure. Number one. I'm going to write the methodology, right? Number one, please write. Obtain the difference. Obtain the difference. Obtain the difference between the oxidation numbers. Between the oxidation numbers. For an equal amount of atoms. Obtain the difference between oxidation numbers for an equal amount of atoms. First, number two, add equal amount of electrons. Equal amount of electrons to the side with highest oxidation number. To the side with the highest oxidation number. I'll explain what is this. Okay. I'm going to explain it. Please type this too. Even in acidic medium or basic medium, we have to follow this step. If you have balanced redox equations in a previous method in your school, just forget this. Otherwise, you will be in trouble. Right? School කොහරි වෙනම කොහරි class එකක මේ lesson එක කරලා තියෙනවා නම් මේ part එක method එක you will be getting a different method. So then try to just erase that. Shift delete kara. Right? Because I'll be giving everything crystal clear. You can't mix up two methods. Just remove that method and take this. Right, okay. See this. Now what I'm saying, when we are balancing a half ionic equation, we have to get the oxidation difference, very important, for equal number of atoms. Then after getting the oxidation difference, you have to add an equal amount of electrons. Okay. For that difference, you should get an equal amount of electrons. Now I'll give an example. See here, zinc converts to zinc 2+. So just give me the answers. What is the oxidation number of zinc? 0. What is the oxidation number of zinc 2 plus? Please don't balance. Listen there. What is the oxidation number of zinc? 0. What is the oxidation number of zinc 2 plus? Plus 2. Then what is the oxidation difference? Difference means gap. Do you know the number line? In the number line, you know numbers. Right? We have numbers. Then I'm asking the difference means the gap between the number line. I mean, the gap in this number line, what is the gap between 0 and 2? Always it's a positive value. This gap is a positive value. If you want to get the algebraic value, get plus 2 and subtract 0. Right? But just imagine the number line and take the difference. It's always positive. Just think from a certain value to the other value we are walking. So what's the gap you find, right? So then here 0 and plus 2. 0 and plus 2. So we know the difference between the two oxidation numbers is 2. So is it an equal amount? Yes. Equal amount of atoms. So I have considered one zinc atom here and here also one zinc atom. Either sides I have considered an equal amount and then I have considered the difference. So then what is the difference? It's 2. Then what you have to do? Add an equal amount of electrons to the side with the highest oxidation. So then to which side you have to add electrons? Always we are adding electrons to the side with the highest oxidation number. So the oxidation number is very pattern electrons. Right? Always. It's a theory. You have to add electrons to the side with the highest oxidation number. Right? 0 plus 2. To which side we have to add electrons? Here, how many electrons? According to the difference, we have to add electrons. If the difference is 3, 3 electrons. Difference is 5, 5 electrons. Is it clear? So here 2 electrons. This equation is balanced now, but we have 2 more steps. Many steps they can be our steps they can, when we are balancing a complete identity equation. But for this equation, this is enough. This is what I mean. Get the oxidation difference and put equal amount of electrons. Shall we do another example? I'll do one different example, right? Cr2O7 2 minus. Cr2O7 2 minus. 1 minute. Cr2O7 2 minus. Convert into Cr3 plus. So that you want to balance this. When you are balancing, please keep remember, we have to get the oxidation difference. When we are getting the oxidation difference, we have to get it for equal number of atoms. Here we have 2 chromiums. Here we have 1 chromium. Don't take the oxidation difference. Make it for equal number of atoms. So as we have 2 chromiums here, definitely we have to make it 2 and take the difference for 2 chromium atoms. When you determine it is oxidation or a reduction, you can find the oxidation number for 1 atom. Oxidation ekadda reduction ekadda කියලා හොයනකොට oxidation number එක 1 atom වලට බැලුවම හරි. But when you are balancing, that's incorrect. When we are balancing, definitely we have to balance the species which is undergoing oxidation or reduction. I mean the atoms. No need to balance oxygens here. Oxygen balance karanna ඕනේ, but you know chromium is undergoing reduction here. So in this side you have 2 chromiums. This side you have 1 chromium. First of all, make it 2. එතකොට ඔයගොල්ලෝ හිතනවාද මේ 1 chromium කරලා ගන්න බැරිද කියලා? බෑ. මෙතන 1 තියෙනවා කියලා මේක 1 කරන්න බෑ. එහෙම ගත්තොත් මේ method එක වැඩ කරන්නේ. This method will not work. You can experiment it. කරලා බලන්න පුළුවන්, right? But we don't trust that, right? So I have practiced this method for few years, right? More than 10 years, right? So then, however, don't find the oxidation number for 1 atom. Take it for 2 chromiums. Okay. So then this side, what is the oxidation number? Not for 1 chromium. I have balanced it for 2 chromiums. You have to take the oxidation number also for 2 chromiums. So that, what is the oxidation number for 2 chromiums? Minus 2 times 7 minus 40. Minus 2 times 7 minus 40. Minus 14 less this 2 minus 12. Then the 2 chromiums should have plus 12. 1 chromium is plus 6. Please don't get 1 chromium. 2 chromiums is the lot. Okay. So then minus 2 times 7 minus 14 less 2 minus 12. Then the 2 chromiums plus 12. So the chromium dekak plus 12. What about this? 1 chromium Cr3 plus is plus 3. The 1 chromium is plus 3. Then you have 2 chromiums plus 6. Difference between the oxidation numbers for equal amount. With an equal amount, you get 2 chromiums. And then when you get the oxidation number also, you have to get the oxidation difference for 2 chromiums, not for 1 chromium. Okay, what is the oxidation difference now? Plus 12 plus 6 is a reduction. What is the gap? 6 and 12, gap is 6. Very good. So how many electrons you have to add and to which side? To which side? Okay. So here 12 and 6, we have the gap is 6. So you have to add 6 electrons to which side? Right? To which side? This side. Left side 6 electrons add. Because you add electrons considering the gap, and always we add the electrons to the side with the highest oxidation state. Is it balanced now? No. Can't balance now. Here you have 7 oxygens, here you have no oxygens. Okay. We have 2 more steps to balance. Right? 2 more steps to balance. But until then, please write this. Write this down. Have you finished? First 2 steps. Yes, Saji, Hamya, Onsala, right? So one information, you have paid your fees to that new account number. I mean, our new institute coordinator. I have received them all. Right? I have received them all. My portion I have received successfully. So then there's no issue with that account number or that institute. So please continue with. If you have any issues, just WhatsApp my mobile number. Other than that, that's okay. That's crystal clear. All your payments, your attendance, your recordings, all the things will be managed by our new coordinator. Please contact her for anything, right? Okay. Yes. So I'll move to the next part. Yes, for that. Number 3, now we have 2 mediums, acidic medium and basic medium. In acidic medium, number 3, number 4 is different from basic medium, right? I mean, we write number 3, 4, but number 3, 4 is different from acidic medium to basic medium. So what I'm doing like this. You can put a topic, I mean, small topic, acidic medium. 1, 2, acidic medium, 3, 4. Is it clear? Then if you want, you can take it as a table. Basic medium, 3, 3 dash, 4 dash, gun. Is it clear? Acidic medium okay. Put a small topic, acidic medium, and write number 3 and 4. Then I'll tell what you have to do in basic medium. Only number 3, 4 is different. 1, 2 is same. Again, acidic basic 1, 2 exactly same. How we know whether it's acidic or basic? In the question they will give. You don't want to know it. If they are giving H plus or sulfuric, acidic medium. If they are giving OH minus or KOH or NaOH, that's basic medium. Right? Shall I write number 3? Okay, this one. I'm not writing in the board, right? Obtain the oxygen difference. Obtain the oxygen difference. Obtain the oxygen difference either sides. Acidic medium. Obtain the oxygen difference either sides. and balance it using relevant number of H2O. Obtain the oxygen difference either sides and balance it using relevant number of H2O molecules. Balance it using relevant number of H2O molecules. Again, oxygen difference එක balance කරන්න මොනවද add කළාද? වතුර දාලා. In order to balance oxygen difference, you add water. මම කියන්නම් මේ මොකද්ද කියලා. හරියට ලියාගන්න. Obtain the oxygen difference either sides and balance it using relevant number of H2O molecules. Okay. So let the point 4. Number 4. Yes. Now obtain the difference between hydrogens. Now obtain the difference between hydrogens. Now obtain the difference between hydrogens. And balance it using relevant number of H plus. And balance it using relevant number of H plus. Now obtain the difference between hydrogens and balance it using relevant number of H plus. Now obtain the difference between hydrogens and balance it using relevant number of H plus. Okay, basic medium I'm going to complete this equation. First equation is balanced. Generally, a redox equation is balancing in two methods: charge, number of atoms. Always an equation is balanced from the charge, and then the equation is balanced from two aspects. Number one is charge, and the number two is number of atoms. Okay. Number of atoms. Atoms are balanced. I'm going to balance this dichromatic equation again, right? See here. Cr2O7 2 minus reduces to Cr3 plus. How to start the balancing? Consider the oxidation difference for equal number of atoms, either sides. Species is chromium, electropositive. 2 chromiums, make it 2. Don't balance oxygens. Just get the difference for chromiums, but for 2 chromiums. 1 chromium is plus 3, 2 chromiums plus 6. Clear? 1 oxygen minus 2. Minus 2 times 7 minus 14. Minus 2 times 7 minus 14. Let's do minus 12. Then the 2 chromiums plus 12. Plus 12. So here plus 12 and here plus 6. What is the difference? Plus 12 and plus 6, the difference is 6. Okay. So you have to add 6 electrons to the side with the highest oxidation number. You have to add 6 electrons to the side with the highest oxidation number. So adding 6 electrons here. Then what you have to do? See the note. Third point. Third point. Consider the oxygen difference either sides. Balance it using what? Oxygen difference එක ගත්තා වතුර ධර්ම balance කරා. ඔන්න බලන්න මම ගන්න. In the left side, how many oxygens are there? මේ බලපුවම මම පේනවා. In the left side, how many oxygens are there? Right. There how many oxygens? Are there? How many oxygens? 7 oxygens. In the right side, how many oxygens? 0. So what is the oxygen difference? You need 7 oxygens to right side. Right? So then how to balance it? In order to balance oxygens, we have to add water. Don't mix up with the previous method, just forget it. Okay, if you have any other method, right? So if you have 7 oxygens, in order to balance oxygens, you have to add water. In one water molecule, how many oxygens are there? In one water molecule, how many oxygen atoms are there? In one water molecule, we have one oxygen atom. So how many water molecules we should add in order to balance 7 oxygens? In order to balance 7 oxygens, how many water molecules we should add? Definitely 7 H2. Now you will be getting hydrogens to your equation. You'll be getting hydrogens to your equation. Can you see? Now hydrogen is available. Now check the hydrogen difference and balance it using H plus. So how many hydrogens? 7 times 2. 7 times 2. 14. Right? 14. So we have 14 hydrogens in right side. We have 14 hydrogens in right side. So in order to balance 14 hydrogens, we have to add 14 H plus. Don't we add 14 hydrogens? No. 14 H plus. H plus add karan. Because acidic medium can H plus. We symbolize karan H plus. H plus means it can be HCl, H2SO4, HNO3, anything. But we write only the ion, H plus. How many H plus we should write? 14. 14 H plus. That's all. Automatically your equation is balanced now. Check the oxygens, balance. Chromiums, balance. Hydrogens, balance. Check the charge. Check the overall charge. It's also balanced. Right. Now let's check the overall charge. Overall charge plus 14. H plus ekaka charge ekiyada plus 1. When you have 14 plus 14. I mean H plus වලින් එන charge එක plus 4. Electron එකක් minus 1. Electron 6ක් minus 6. Then dichromate. Dichromate, what is the charge? Cr2O7, 2 minus. Within the charge. Charge of one dichromate is minus 2. If you have 2 dichromates, that's minus 4. If you have 3 dichromates, minus 2 into 3, minus 6. And my charge again. Then the dichromatic charge means this charge. One dichromate charge is minus 2. How many dichromates we have? Only one dichromate. So what is the charge here? Minus 2. Then just add this charge and see. What is the charge in left side? Minus 6, minus 2, it's minus 8. So plus 14 minus 8. Plus 14 minus 8. What is the answer? Plus 6. So in your left side, the overall charge is plus 6. Definitely, in the right side also, the overall charge should be plus 6. Because a redox equation is balanced from the number of atoms as well as the charge. Just see the charge in right side. One chromium is plus 3. One chromium is plus 3. How many chromiums you have? You have 2 chromiums. That means plus 6. Water, 0 charge. Water charge right? Then the overall charge is plus 6. Charge is balanced. So do we want to prove this charge is balanced? No. It's better to know. Right? Then again, no. Charge is automatically balanced. In the exam, they are not asking to balance it and prove it. But you should know if you have balanced the equation is balanced from the number of atoms as well as the charge. Okay, please write this down. I mean, after writing that 0.34, you can put this again. 34 livered පස්සේ ආයෙ මේක ලියා ගන්න පුළුවන්. We'll do more examples, right? Right. Right, okay. I finished this. Just give me a sign. I want to move the basic method. And basic again, right? Okay. Don't mix next week, right? Next week I'll be discussing many more examples like this. Today is the theory session, right? I'll discuss some examples. Next week I'll be discussing all the homeworks, right? With that Redox tube. Do not miss. Okay. We have write basic medium. By the topic, basic medium. This number 3, 4. We should repeat in the basic medium. So in the basic medium, write number 3. Get the charge difference. Obtain the charge difference. You can put it as 3 dash if you're mixing up. Right? So the basic medium will dash 3 dash 4 dash. Obtain the charge difference. Proceed again. Obtain the charge difference. Obtain the charge difference and balance it using relevant number of OH minus ions. Obtain the charge difference and balance it using relevant number of OH minus ions. Obtain the charge difference and balance it using relevant number of OH minus ions. Obtain the charge difference and balance it using relevant number of OH minus ions. Number 4. Then obtain the hydrogen difference. Then obtain the hydrogen difference. Then obtain the hydrogen difference. And balance it using water. Balance it using relevant number of H2O molecules. Or just write balance it using water. Obtain the difference between hydrogens. Obtain the difference between hydrogens. And balance it using relevant number of H2O molecules. And balance it using relevant number of H2O molecules. Balance it using relevant number of H2O molecules. Then mention, put a star mark and write at the end as overall sentence, right? Overall sentence. Every redox equation is balanced. Every redox equation is balanced. Every redox equation is balanced with the number of atoms and the charge. Every redox equation is balanced with the number of atoms and the charge. Right? If you find the charge either sides, it's balanced. Number of atoms either sides, it's balanced. Every redox equation is balanced with the number of atoms and charge. So let's get the first example. A topic, balancing half ionic equations in acidic medium. Balancing half ionic equations in acidic medium. Balancing half ionic equations in acidic medium. Okay, balance this. MnO4 minus to Mn2 plus. So you should rewrite it and balance it. Start balancing it. I've given the procedure. Get a pencil and start. MnO4 minus Mn2 plus. Determine the oxidation number. Change at equal amount of electrons with the side that is having the highest oxidation number. Check the oxygen difference. Put water. Check the hydrogen difference. Put H plus. Yes, 1 minute. MnO4 minus to Mn2 plus. Acidic medium. You have to determine this is as an oxidation or reduction before balancing. No, this could be oxidation or reduction, anything. We can balance it. Just follow the procedure we have written. Just follow the procedure we have written. Check the oxidation number of this manganese. Get the gap. Put the electrons. Just follow it. You can. Right, okay. Yes. Imbalance. See here. The balance ka level තියෙන ගොඩක් අය. හොඳයි. අපි next week පොඩි competition එකක් වගේ තියෙන balance කරන්න. අද මම balance කරන්න. දැන් මොකක්ද balance කරා මේක? හරි. පුතා ඔයගොල්ලෝ balance ද කියලා කොහොමද check කරගන්නේ? Check the charge difference. Check the charge in left side, overall charge. Check the charge in right side. If the charge is balanced, your equation is balanced. No need to check by me. මම check කරන්න ඕනේ නැහැ. දෙපැත්තේ charge එක balance කියන්නේ automatically balance. Right? So see here manganese. Consider one manganese atom, right? One manganese atom. So then minus 4 times 8. Sorry, minus 2 times 4 minus 8 plus this one. Then MnO4 minus 10, right? Minus එක දැක්කේ නැද්ද දන්නේ. Then minus 8 වලින් මේක අඩු කරන්න ඕනේ minus 7. එතන මේ manganese එක plus 7. හරිනේ? plus 7. එතන මෙතන manganese එක plus 2. plus 7 plus 2. What's the difference? Plus 7 plus 2, the difference is 5. Difference එක 5. හරිනේ? Difference එක 5. Then what we have to do? We have to add equal amount of electrons with the side that you are having the highest oxidation number. The oxidation number එක වැඩි පැත්තට මේ electrons පහ add කරනවා. කොහොමද oxidation number එක වැඩි පැත්ත? මේ side එක. Right? So then you can add 5 electrons. Then is it balanced? No. Imbalance වෙන්නේ. Electrons දාපු ගමන් balance වෙන්නේ, right? Get the oxygen difference. See whether there's any oxygen difference. Yes. Here 4 oxygens, here no oxygens. In order to balance oxygen difference, we have to add water. How many water molecules? 4 oxygens, we should add 4H2O. 4H2O. 4 oxygens means 4H2O. Then we should consider the hydrogen difference. In order to balance the hydrogen difference, we have to add H plus. 4 times 2, 8. 4 times 2, 8. So we should add 8H plus. 8H plus. 4 times 2, 8. 8H plus. Right? That's the point. 4 times 2, 8. 8H plus. So then check the charge. Now in this side, what is the charge? Water, no charge. Mn2 plus, that's a charge, plus 2. I mean right side charge is plus 2. Definitely the charge in the left side also plus 2. The left side got plus 2 when the morning. Right, maybe minus 5 electrons. Sorry, 5 electrons can kill charge again. Minus 5. Minus 5. Right? 5 electrons can minus 5. MnO4 minus. MnO4 minus එකක charge එක කීයද? මේ එළියලා බලන්න හරි ලේසි. MnO4 minus. දෙකක charge එක minus. minus 1. Right. ඒ කියන්නේ minus 1 උන පස් දෙනෙක් හිටියට minus 5. 8H plus. H plus එකක charge එක කීයද? plus 1. 8ක් ඉන්නවා. හරි? plus 8. අන්න simplify කරලා. simplify කරලා බලන්න. Right? plus 8 minus 1 minus 5. කීයද value එක? අන්න පුතා කියන්නේ. plus 2. හරි නේද? plus 2. ඉතින් plus 2 තමයි right side එකේ charge එක. දැක්කද? charge එක balance වුණා කියන්නේ equation එක balance. හරි. balance. ඒක තමයි case. දැන් මේ හරි ලේසි මේක පොඩි තියෙන thrill එකක්. හරි. මේක පොඩි ජොලියක් තියෙනවා. equation එක balance කරලාම බලන්න. මම ඉතින් class එකේ කාලේ මේකට හරි ආසයි. මම ගියපු class එකේ අනෙක් class වල හැම class එකෙම tubes හොයාගෙන කරා. මේ redox balancing tubes හොය කරා. ඒ කාලේ මම class ගියේ පදවි times එකේ දෙවරන්ස් එකේ ගිහලා තියෙනවා. එරෙන්න ඔය අනිත් classes ගොඩක් ඒවා tubes හොයාගෙන මම මේ කාලේ කරා. මට මතකයි. හරි. ඉතින් ආසහන්න කරේ. ඒගොල්ලන් මේක ආස වුණාම මේ වගේ questions ගොඩක් හොය කරන්න හිතේ. එතන මේකෙන් තමයි chemistry පුළුවන්. ආස වුණාම පුළුවන්. right? හොඳයි. balance නැති equation එක. අපි තව එකක් balance කරමු basic medium. හරි. basic medium එක balance කරමු. මොනවා ප්‍රශ්න තියෙනවා මම අහන්න WhatsApp එකේ අහන්න මම උදව් කරන්න. right? මේ physical states දාන්නේ නැහැ. අපි දැනට physical states දාන්නේ නැහැ ඉස්සරහට. Physical states ගැන කතා කරමු. right? Physical states means A equals those cases. right? We balance the equation. Okay, next one. මම එකක් basic medium balance එකක් කියලා දෙන්න. I'm going to erase this, right? So මේ වගේ equations තියෙනවද මේ සතියේ balance කරන්න? Equations 20කට වැඩිය තියෙනවා. අන්න homework වල තියෙනවා. right? පුතා basic medium. MnO4 minus දාගන්න. එතන මේක පොඩ topic එකක් දාගන්න. Balancing half ionic equations in basic medium. Balancing half ionic equations in basic medium. අද ගොඩක් වෙලා නැති නිසා equations හුඟක් කරන්න බෑ. Next week කරමු. Balancing half ionic equations in basic medium. MnO4 minus 2 MnO2. First two steps කරලා දෙන්න මම. First two steps විතරක් කරන්න 3 4 කරන්න එපා වරදිනවා. හරි. Oxygen difference එක ගන්න එපා. Get the first two steps and add the electrons. How we know it is basic medium? In the exam they will be giving. Actually, we don't want to give it. If I am giving MnO4 minus in basic medium, you should know because it is a standard reduction. MnO4 minus reduces to MnO2. It's the difference, right? In medium. So in basic medium, we don't use H plus. We use OH minus to balance. In basic medium, we don't use H plus. We use OH minus to balance. Okay, get the first step. MnO4 minus MnO. How many electrons are to which side? Add the electrons. Electrons 6 එනවද? තාම difference එක ගන්න බැරි ප්‍රශ්න තියෙනවනේ. හොඳට difference එක ගන්න බෑ. Get the difference well. For one manganese atom either sides we have to get the difference. Not 6 electrons. Right? You have to be precise from the first step. Otherwise your equation is definitely not balanced. Right? Just focus it well. Right, Putala. MnO4 minus. What is the oxidation number here? What is the oxidation? Minus 2 times 4 minus 8. Right? Minus 8 less this one. Minus 7. Manganese is plus 7. Then manganese plus 7 කියලා දැන් හොඳට මතකයි. දැන් මෙතන manganese එක කීයේ? ඔයස manganese එක plus 2 නෙමෙයි. 1 oxygen is minus 2. 2 oxygens minus 4. This manganese is plus 4. This manganese is plus 4. 1 oxygen is minus 2, 2 oxygens minus 4. This manganese is plus 4. So plus 7 plus 4, the difference is 3. Plus 7 plus 4, the difference is 3. හරිද පුතා? හොඳයි මම බැලන්ස් කරන්න බලාගන්න basic medium. Add the electrons. What are the electrons add කරන්නේ? To the side with the highest oxidation number. So we have 7. We should add 3 electrons to here. Now what is the next line? Next one is හොඳට බලන්න basic medium මොකක්ද නේද තියෙන්නේ කියලා. note එක බලන්න. දැන් බලන්න. Right. මොකක්ද කියන්නේ? Get the charge difference. හොඳට අහගන්න. Get the charge difference. Basic medium balancing පොඩක් අමාරුයි. Get the charge difference either sides and balance it using relevant number of OH minus ions. Now, හොඳට අහගන්න. මේක තමයි basic medium balance කරන්න තියෙන ලේසිම method. ඔබ ඉස්කෝලේ ඉගෙන ගන්න නැහැ මේ method. Right? මෙන්න මොනවා හරි කියනවා මේක add කරලා H+ දාලා ඒක erase කරලා water දාලා මොකක්ද කියන්නේ. Right? ඉතින් මේක මම වෙනස් කරලා උගන්වන එකක්. මම ක්ලාස් එකේදී ඉගෙන ගත්තත් මේ method එක නෙමෙයි. Right? මේක basic medium වලට මාර ලේසි. එන surprise වෙනවා මේ equation එක වෙනස් වෙන්නේ. අන්න බලන්න. ආසාවෙන් ඉගෙන ගන්න. Now, in the left side, what is the charge? Charge කියන්නේ overall charge. ඔක්කොම charge එකයි. I haven't added OH minus, right? Still, I haven't added OH minus. Don't add OH minus at the beginning. Now, what is the amount of the charge here? එකල දෙන්න පුතා charge එක. එක electron එකක් -1, electrons තුනක් ඉන්නවා -3. MnO4 minus එකයි ඉන්නේ -1. ඒතර overall charge එක -4, right? On the left side එකේ charge එක කීයද? -4. What is the charge in the right side? Charge in the right side? 0. MnO2 there's no charge, right? මේ charge එක නෙමෙයි. charge එකක් තියෙනවා මෙතන mention වෙන්න එපා. There's no charge. Right. My question is, in order to balance the charge, we should add OH minus. In OH minus, we have negative charges. 1 OH minus means -1. 1 OH minus means -1. My question is, to which side we have to add OH minus? To which side? Left or right? This is -4. Here 0. So the charge එක balance වෙනවා කියන්නේ මෙහෙ -4 නම් මෙහෙ +4 වෙන එක නෙමෙයි. මේ පැත්ත -4 නම් මේ පැත්තත් -4 වෙනවා. ඒක තමයි balance වෙනවා කියන්නේ. To which side we have to add OH minus? Which side? Right side. මේ right side කියලා කියන්න බෑ. මේ right side, මේ left side. Right side එකට තමයි OH minus add කරන්න ඕනේ. කීයක්? Yes, how many OH minus ions? How many OH minus ions? minus 4. Right. So we add 4OH minus. 4OH minus because we are supposed to balance the charge. Right? Okay, now the charge is balanced. Final step. Final step. Balance the hydrogen. You have to balance the hydrogen difference using what? Hydrogen difference එක වතුර දාලා balance කරන්න. In order to balance the hydrogen difference, add what? Can't we consider oxygen difference? Actually, we can. But the issue is oxygen is available everywhere. Oxygen හැමතැනම තියෙනවා. Difficult to balance. Check the hydrogen difference and then see to which side you need hydrogens. To that side, put water. But in one water molecule, you have two hydrogens. In one water molecule, you have two hydrogens. Now, how many hydrogens in the right side? 4 hydrogens. Left side, no hydrogens. No hydrogens. Then you should balance 4 hydrogens to this side. When you are putting 4 hydrogens, you don't put 4H2O because one water molecule carries 2 hydrogens. So then how many water molecules you have to put to the left side? That is, how many water molecules? In order to balance the hydrogen difference, we have to put water. In that side, we have 4 hydrogens. This side, no hydrogens. So in order to balance hydrogen, put water. I water add කරන්න. මේක තමයි method එක කියන්නේ. I කියලා කියන්න බෑ. Right? 4 hydrogens, we have to add 2H2. Now, how we confirm whether the equation is balanced? Just see the oxygens. Automatically, the number of oxygens are balanced. अब මේක oxygen balance කරේ නැහැ නේ. බලන්න oxygen auto balance. 4 oxygens, 2 oxygens. 6 oxygens available in the left side. Right side, 4 oxygens, 2 oxygens, 6 oxygens available in the right side. Oxygens automatically balance. Automatically balance. That's the success. Right? Please write this together. So is it oxidation or reduction? +7 to +4, oxidation number is decreasing. It's a reduction. So this is basic medium. I'll do 2 examples and finish the session, right? I'll do only 2 examples and finish the session. So you can see in our tute, we have many more examples. I have added this tute already to your WhatsApp group, right? Redox exercise. So you have to finish this 20. May 20 නම් කොහොමද ඉවර කරන්න ඕනේ? Determination of the oxidation numbers. And then here, write balance half equation. Can you see? Write the balance half equation. So then acidic medium, here you have 16. Right? I have given the species. Balance half equation. Can we then correct? Then this is basic medium. Right? Next week discuss කරන්න how to obtain balance ionic equation කියන. මේවා match කරලා කොහොමද මේ balance ionic equation ගන්න කියන එක next week discuss කරමු. Right? Okay. එතකොට මේ part එක පොතලට මේ 20 වෙනකන් කරන්න. To this 20 you can do. Right? So ඉතින් හොඳට dedicate කරලා කරන්න. ඒක ගොඩක් improve වෙන්න පුළුවන්. හරි අපිට exercise equations දෙකයි කරන්න. මට විනාඩි 3ක් විතර දෙන්න. ඔය තව examples දෙකක් මම discuss කරන්න අපිට හොඳයි. Shall I erase this? Right. So don't mix up the medium, right? In the acidic medium, one procedure, basic medium, another procedure. This half ionic equations. A full equation means we should add a reduction and oxidation together to get a complete equation. එක අපි ළඟ විදිහට කරනවා. හරි? මේ සතිය අපි කරන්නේ reductions වෙනම balance කරනවා, oxidations වෙනම balance. Right? So if you get electrons to your right hand side, that is oxidation. If you get electrons to your left hand side, it's a reduction. Okay? Easily you can identify. This one. H2O2 to water. Balance it in the acidic medium. Balance it in the acidic medium. Basic medium. Nitrate to ammonia. Nitrate to ammonia. Balance it in the basic medium. These are the final equations. Acidic, basic. Start. So you have 20 equations in your tute. So in which atom we have to consider the oxygen difference? It's really important. Don't consider hydrogen here. Consider oxygen here. When you get the oxygen difference, consider it for oxygen. Then the most important thing is, when you get the oxidation difference, you should get it for equal number of atoms. So don't miss that. Equal number of atoms. Here you have 2 oxygens. Here you have 1 oxygen. So do you consider the oxidation difference for 1 oxygen? It's incorrect. Definitely you have to consider the oxidation difference for balanced number of. So here 2 oxygens are there, right? Then oxygens දෙකක් තියෙනවා නම් definitely මේ side එකට 2 oxygens කරන්න. No need to balance hydrogens. You should balance oxygen because oxygen is the atom which will undergo oxidation and reduction. Then get the difference. Then do we get the difference for 1 oxygen atom? No. Balanced number of oxygen atoms. Balanced number of oxygen atoms. So what is the balanced number of oxygens? 2 oxygens. Get the difference for 2 oxygens. I mean get the oxidation number of 2 oxygens. Get the oxidation number of 2 oxygens, then only consider the difference. Okay, carry on. Yes, some students, you have balanced the equation and send it to me. Very good. So try to do this as a hobby, right? Small hobby. Balancing equations. You got a competition apply කරන්න පුළුවන්. At the end, you should balance the charge and number of oxygens. If you have balanced the charge, if you have balanced the number of oxygens, your equation is balanced. I'll balance the first one now. I finished the first one. Only the first one. Yes, this any? Good. Petma. Great. So check whether you have balanced charge. Charge එකත් balance වෙනවද කියලා automatically බලන්න. Acidic medium එක අපි confirm කරගන්නේ charge balance වෙනවද කියලා. Basic medium එක confirm කරගන්නේ oxygen balance වෙනවද කියලා. හැමයි confirmation එකට යන්නේ. Right? So I'll balance it. Now 2 oxygens. In H2O2, oxidation number of 1 oxygen is -1. 2 oxygens -2. In water, the oxidation number of 1 oxygen is -2. In water, the oxidation number of 1 oxygen is -2. But we have 2 water molecules. So this is -4. Balance කරගත්ත ගානට තමයි difference එක. Balance කරගත්තේ oxygen දෙකකටනේ. ඒතර එක්කෙනෙක්ට oxidation number එක ගන්නෙ නැහැ. දෙන්නෙක්ට ගන්න. ඒතර එක්කෙනෙක්ට ගත්තොත් මොකද වෙන්නේ? වැරදිනවා. මේකයි වෙන්නේ. So then -2 and -4. Number line එකේ gap එක කීයද? Between -2 and -4 number line එකේ gap එක කීයද? Positive value එකක් එන්නේ. මෙතන නම් ඇවිදගෙන යනවා කියලා හිතන්න. Then if you are walking to here, the gap is 2. Right? -2 to -4. So then to which side we have to add 2 electrons? සමහරට එක වර්ධින්නේ. To which side we have to add 2 electrons? To the side with the highest oxidation number. I mean out of -2 and -4, which one is the highest oxidation number? -2 and -4, which one is the highest oxidation number? එකෙන් highest එක පොඩි කාලේ කියලා දෙන්නේ නේද? Right? So then it is -2. So you have to add 2 electrons to this side. Then what you have to do in the acidic medium? See the note. Take the oxygen difference if it is available. Do you have any oxygen difference? No. 2 oxygens, 2 oxygens. So then your equation is balanced? No. Check the hydrogen difference. Check the hydrogen difference. Oxygen difference එකක් නැතත් කමක් නැහැ. ඊට පස්සේ check කරන්න hydrogen difference එකක් තියෙනවද? So how many hydrogens here? 2 times 2, 4. How many hydrogens here? 2. So that's the hydrogen difference. That's the hydrogen difference. In order to balance the hydrogen difference, put H plus. 2 times 2, 4. And here 2. How to balance the hydrogen difference? We use H plus. How many H pluses we have to use? 2. So use 2 H plus. Equation is balanced. This side the charge is 0. This side overall charge is 0. Right? -2 plus 2. -2 plus 2. Overall charge is 0. The charge is 0. Equation balance. This is a reduction. Okay. Hydrogen peroxide reduces to water. Last one. Last one. Nitrate to ammonia. Basic medium. Start balancing it. But again, OH minus kiya add kara de. Mega balance karana OH minus kiya add kara de, water kiya add kara. Nitrate to ammonia. Start balancing it. Which item we have to consider? Nitrogen. Basic medium. So you can collect the recording by Sunday. This Sunday with the recording again for one. It arrive again. Homework sticker head on them karana pota. You take a homework sticker head on them karana. Next Friday, next Thursday karana pota. Bahut mata karna. Right. Try to do your homeworks within 3 days after the class. If you have balanced Manuga, okay. I think your equation is balanced. OH minus with what I go mathi. We don't know balance than again. Nitrate to ammonia. It's a bit tricky. That's what I have selected that. Basic medium, right? Nitrate to ammonia. So I'll erase this one and balance it, right? So right. Still you have the time. First step, getting the oxidation difference. Nitrogen, what is the oxidation number? +5. This nitrogen, what is the oxidation number? Ammonia के nitrogen है oxidation number क्या? Don't mix up. Hydrogen is +1, 3 hydrogens +3, nitrogen is -3. ගොඩක් කාට gap එක වර්ධින්න. අන්න difference එක 2 කියලා කියන්නේ. No, difference එක 2 කියලා ගත්තොත් වැරදි. Number line එකේ ඇවිදගෙන යන්න බලන්න -3 to +5. ඈ number line එක අනින් බලන්න. 0 -3 +5. ඒක තමයි මම එහෙම කතා කරන්නේ. Right? I mean, get this idea. From -3 to +5, if you are moving, what is the gap? Gap -3 to +5. If you want to get it in the algebraic method, +5 minus -3. The gap is 8. On oxidation difference, right? Between -2 and -4, the difference is 2. Between -2 and +4, the difference is 6. Always draw a number line and see the gap. Then easily you can understand it. -1 plus 2. -1 plus 2 gap is 3. Number line එකෙන් හිතුවනම් this. හරි අඩු කර කර ඉන්න දෙක. Right, okay? +5 3, එතන කේද 8. So then you have to add 8 electrons to each side. The side with the highest oxidation number. So you put 8 electrons here. So then what is next? Balancing the charge. So see the charge. Right side here 0. Left side here 8 electrons means -8. And then nitrate, 1 nitrate, what is the charge? -1. So what is the charge in the left side? -9. In order to balance the charge, we have to add OH minus. So then how many OH minus ions we are adding? -9. In order to balance OH minus, we have to add, in order to balance -9, we have to add OH minus. Here 9 to this side. 9 OH minus. ගොඩක් අය OH minus උත් add කරා. hydrogen balance වෙන්නේ. Right? ඒ මොකද? ඔයගොල්ලෝ පේන්නේ මෙතන මේ hydrogen 9 එක විතරයි. Now in right side, how many hydrogens are there? You just take 9 hydrogens. No. In ammonia also you have 3 hydrogens. Right side, total number of hydrogens you have. Total hydrogens. So here 9 hydrogens and here 3 hydrogens. The ඔක්කොම hydrogens here. Huh? How many hydrogens in total? Right? That's the point. So 9 hydrogens and here 3 hydrogens. So 9 plus 3, 12 hydrogens. In order to balance 12 hydrogens, put 6H2. Right? Just write 6H2. 6H2. So our equation is balanced. Check the oxygens. 9 oxygens. Yes, 6 oxygens plus 3 oxygens. 9. Either sides of the equation, we have 9 oxygens. It's balanced. Right. That's all. So I think you have enjoyed the session, right? So this part, redox. So then try to get the dude and balance the half ionic equations as soon as possible. So try to complete the dude, right? Okay. So next week we'll be meeting and we'll be discussing the questions, and then we'll be moving to balance ionic equations and balance chemical equations. Until then, stay safe. Good night.